Hello everyone, I am Dr. Tushar Chaudhary from Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. I welcome you all to the third lecture session on fuel cell technology. In this module, we will going to cover hybrid energy system. By end of this module, you will able to answer the following point. First, you are able to explain what is hybrid energy system. Second, what is the need of hybrid energy system, why it is been important, and third, what are the various types of hybrid energy system and how they work. First, we starts with the introduction. A hybrid energy system is a combination of a two or more different energy sources or technologies that can work together to generate, store and deliver energy for various applications, including electricity generation, heating, cooling and transportation. These systems are designed to optimize energy production, improve efficiency and enhance the reliability of the integrating multiple energy sources. Let us consider one example. Here system 1 is representing a solar panel which converts solar energy into electrical energy. System 2 represents the wind turbine which converts wind energy into electricity. Now, these two systems are integrated with each other called solar wind hybrid energy system. This hybrid system generates large amount of electricity. So, here we have some key points components, that is some key components of hybrid energy system. First, we have the primary energy source. These are the main source of energy in hybrid system that can include renewable sources like solar panel, wind turbine, biomass as well as the conventional source like fossil fuel or nuclear power. Second, we have the energy store. Hybrid energy system often include energy storage solution such as battery thermal storage or pumping hydro storage. Energy storage allows excessive energy generated during the period of high availability to be stored for later use when energy production is lower. Third, we have control and monitoring system. Advanced control and monitoring system are essential for optimizing the operation of hybrid system. This system adjusts the energy sources and storage element in real time based on demand availability and other factor to maximize efficiency and reliability. Fourth, we have energy, that is conversion technology. Hybrid energy system may incorporate conversion technologies like inverter, fuel cell or micro turbine to convert energy from one form to another or to provide power backup when needed. Some benefits of having this hybrid energy system. First, we have the improved reliability. Combining multiple energy sources can enhance reliability, ensuring a continuous power supply even when one source experience downtime or variability. Second, increased efficiency. Hybrid energy system can achieve higher overall energy efficiency by using the most appropriate energy source for each situation, reducing waste and optimizing energy production. Third, we have energy independence. Hybrid energy system can reduce dependency on single energy source, especially fossil fuel, by incorporating renewable energy sources, leading to generate energy security. Fourth, we have environmental benefit. By integrating renewable energy sources, hybrid system can produce a very good amount of energy by reducing greenhouse gases emission and minimizes environmental impact of energy production. There are some certain applications of hybrid energy systems we are also going to have. From this figure, we can see a wide variety of hybrid energy system where we can implement. First, we have the remote power generation. Off-grid homes and cabins, hybrid energy system can provide a reliable electricity to remote or off-grid residents by combining solar panel with wind turbine generator or energy storage system. Second, we have rural electrification, micro grid or for villages. Hybrid system can be used to electrify rural or remote areas where to access to main power grid is limited. They often integrated solar, wind or diesel generator. Third, we have island and coastal communities. In Iceland power, many islands and coastal regions are used hybrid energy system to reduce reliance on expensive imports of fossil fuel and transition of renewable energy sources. Fourth, in the sector of telecommunication sector, cell towers, remote cell towers often employ hybrid system to ensure uninterrupted power supply, combining solar panel, batteries and backup generators. In military application, forward operating bases, hybrid energy systems are used in military operation to reduce the logistical burden of fuel delivery and minimizes the environmental footprint. Sixth, we have the industrial and commercial sites. Mining operation, remote mines can use hybrid system to power their operation, combining renewable energy sources with tradition. Industrial and commercial sites, here in mining operation, remote mines can use hybrid system to produce power their operation, combining renewable energy sources with traditional generator. Agriculture facility, greenhouse and farms can employ hybrid energy system to reduce energy cost and enhance sustainability. Seventh, we have transportation, hybrid electric vehicle combines with internal combustion engine with electric propulsion system to improve fuel efficiency and reduce emission. Eighth, we have maritime industry, hybrid ships, hybrid power system in ships integrated various energy sources such as diesel engine, battery and even wind and solar to reduce fuel consumption and emission. Ninth, we have the data center power backup. Data centers often use hybrid systems to ensure the uninterrupted power during outage, combining grid power with on-site generator and energy storage. 10th, the environmental monitoring and research, remote sensor and instrument, hybrid energy systems are used in various equipments and sensor in remote or environmental sensitive location for research and monitoring purposes. 11th, the disaster relief and emergency response, mobile power unit, hybrid energy system provide essential power during disaster relief efforts, combining solar and wind generated power with energy storage. Even for hydrogen production also, renewable hydrogen hybrid systems can be used to produce hydrogen using renewable energy sources, which can be used as a fuel in a fuel cell for a electricity generation or as a clean fuel. In hybrid grids, smart grids utilizes, companies are exploring hybrid grid solution that combines traditional grid infrastructure with distributed energy resources like solar and wind to improve grid resilience and reliability. Hybrid energy systems are versatile and adaptable, making them valuable solution in various sectors where energy reliability and sustainability and cost effective are critically considered. They play a significant role in reducing reliance on fossil fuels and mitigating the environmental impact to green hydrogen production when the energy is been required. Sixth, we have the need of hybridization. In this slide, we are going to discuss about the need of the purpose of the hybridization. Hybridization in the construct of power generation system is integrated for multiple sources of energy to create a more efficient, reliable and sustainable energy solution. Switching between the source when one is inactive reduces the unpredictability inherent in renewable energy and improves the sustainability and stability of the electricity supplied. Some of the key advantage of hybrid energy system or hybridization are as follows. First, we have enhanced reliability. Hybrid system can provide more reliable energy supply to combining multiple sources. This is particularly important in critical application where uninterrupted power is essential, just as for example in hospital, data centers and remote installation. Increased efficiency by utilizing the strength of different technologies or energy sources, hybrid system can operate more efficiently. For example, combining renewable energy source with backup generator can optimize power generation and reduce the fuel consumption. Third, we have energy cost saving. The hybrid system can help in reducing energy cost by using cheaper or more abundant energy source when available. This especially benefits in a application where energy expense are significant proportion to operation cost. Fourth, environmental benefits. Hybrid system can reduce greenhouse gases and environmental impact. Incorporating the renewable energy sources such as like solar and wind into hybrid system helps in lower carbon footprint and mitigates pollution. Fifth, we have the energy independence. Hybrid energy system can provide energy independence by relying on mixing of energy source, reducing dependence on single source or the grid. This can enhance the energy security and resilience. Sixth, we have the flexibility development. Hybrid system can be customized to meet the specific need and challenges. They can be designed for a wide range of application from remote power generation to grid integration and transportation. Seventh, we have the load matching. Hybrid system can optimize to match energy production with energy demand. For instance, combining solar panel with energy storage can ensure power availability during peak demand times or when solar energy production is low. Eighth, we have peak saving in hybrid system. When the energy storage excesses energy is stored, when the production is high and released during the peak demand period, helps to reduce the electricity cost. Ninth, we have the scalability. Hybrid system can often be expanded to a scale down to accommodate changing energy need. This scalability makes them suitable for a variety of application from small residential system to large industrial installation. Tenth, we have remote access. In off grid or remote location, hybrid system can provide access to reliable power source, enabling the development and improving the quality of life for commodities. The lack of connection to traditional grid. 11th, we have the reduction transition losses. By generating power closer to the point of use, hybrid system can reduce energy loss associated with long distance transmission, which is especially beneficial in remote area. 12th, we have technological synergy. Combining different technologies can lead to synergy where the strength of one technology compensate for the weakness of another. For example, using renewable energy source with energy storage can overcome the intermediate energy production. 13, that is grid stability. In grid connection application, hybrid system can contribute to energy stability by providing suitable power backup during grid outage or supporting the grid with distributed generation. Overall, an hybrid energy system offers a versatile and adaptability approach to meet the energy need efficiently, sustainably and reliably across a wide range of application, contributing to economic, environmental and energy security benefits. Now, here we are going to discuss about the various types of hybrid system. Here various distributed power generation system has been illustrated. The combination of this system converts into hybrid system. Here renewable and non-renewable and storage system are combined together for a hybridization. In renewable, solar, wind, hydro, biomass, tidal, various systems are being considered, whereas in non-renewable, micro turbine, in combustion engine, gas turbine system are considered. And lastly, for storage, flywheel, batteries and superconducting magnetic energy storage are being used. Right now, some phase change material are also being used, which is in a research phase over here. Some common types of we are going to discuss in this module. So, first we have the hybrid system, which integrates solar, wind energy system. From the figure 1, the experimental setup of combined PV ray and wind turbine has been shown over here. These are the reference from where this figure has been taken over here. From this figure we can see the power generation, how it is going to be done. From figure 2, a block diagram has been shown over here. The figure 1 illustrates the practical model and figure 2 illustrates the block diagram of solar wind hybrid energy system. This hybrid energy system operates by harnessing energy from both sunlight and wind. Solar panel converts sunlight into electricity, while wind turbine captures the kinetic energy of the wind. The electricity generated from both the sources is then combined, allowing for more consistent power output as a solar and wind resources often compete with each other. Optionally, excess energy can be stored in a battery for a later use, and the system can be connected with an electrical grid to export surplus power or draw it from when it needed. A control and monitoring system oversees the operation of the component, ensuring the efficient energy generation and distribution. This integration of solar and wind power source provides a reliable and sustainable solution for the area with varying weather condition or fluctuating energy demand. The basic components are given as follows. Here we have solar panel array, inverter for solar panel, wind turbine, generator for wind, a charge controller which is an optional one. In some system, a charge control may be included to regulate the charging of battery if they are a part of system. This prevents overcharging and extend the lifespan of battery. Sixth, we have the battery storage, which is also an optional. If the system includes energy storage, excess electricity from both the solar panel and the wind turbine can be stored in this battery. Seventh, we have the grid option, grid connection, which is an optional. This allows surplus electricity to export to the grid when generation exceeds the demand and to draw the power from the grid when needed. Eighth, we have the load distribution system, then control monitoring system. So, these are the systems in this. Next, we are going to move towards the another hybrid system, which includes the fuel cell with gas turbine. From this figure, we can see that the figure number 3, the fuel cell and gas turbine. This is a figure has been taken from a research paper. The source has been mentioned over here. We can see that how this waste heat can be recovered and some energy and exergy can be calculated from this hybrid system. A fuel cell gas turbine hybrid system here has been shown in figure 3 combines the benefit of both fuel cell and a gas turbine technologies for efficient electricity generation. In this system, fuel cell converts hydrogen rich fuel, usually we are going to use natural gas, directly into electricity through electrochemical process, offering high efficiency and low emission. The waste heat from the fuel cell is then used to drive the gas turbine, further generating additional electricity through conventional combustion process. This setup, known as combined cycle, significantly enhance the overall efficiency by utilizing both chemical reaction in the fuel and the combustion process in the gas turbine. The system flexibility allows for a seamless transition between the different load demand, make it as a promising solution for power generation with reduced environmental impact and increased energy efficiency. Next, we are going to move towards the next hybrid system, that is solar hydro hybrid system. Figure 4 shows the hybrid system which includes the PV battery, photovoltaic system, battery and hydro system to harvest rainfall for power generation over here. The source from here where we have taken this figure has been mentioned over here. The integration of rainfall based on hydro system with solar PV battery is very interesting. Here we can see from this figure 4, when the PV system fails to produce power due to rain, hydro system will still be producing power by utilizing rainwater. Thus, novel hybrid PV battery hydro system present in this study can ensure high reliability of power supply with less number of expensive battery. Further, when PV batteries hydro system with pumped storage system is optimized, it can lead to generate reliable power with comparative lower unit cost. In next slide, we are going to have the another hybrid system, that is fourth hybrid system, where the solar biomass hybrid system we are going to consider. Here in figure 5 shows the solar biomass hybrid system. The source has been mentioned over here. The system would be convenient. This type of system is very convenient in rural commodities where the farmers have large amount of biomass in form of agriculture waste that can be combined with solar power to choose the urban rural electricity gap and help the environment in the process. A solar biomass hybrid system combines solar energy and biomass energy technology to generate electricity. From this figure 5, the solar panel converts sunlight into electricity through photovoltaic cell, while biomass energy is produced by burning organic material. Both sources contributes a shared electrical output. Optionally, excess energy can be stored in a battery and the system can be connected to a grid to export the surplus power and drawing from it when it is been required. This integration ensures a reliable power supply as solar energy provides a steady source during the day, while biomass offer consistent energy regardless the weather condition. So, as per the demand, this type of system is widely used in the rural area. Next, we have the another hybrid system, that is fifth configuration, where fuel cell solar hybrid system we are going to have. The figure 6 shows the fuel cell solar power hybrid system. The reference from where this figure has been taken has been shown over here. Solar fuel cell hybrid system operates by harnessing energy from sunlight and converting it into electricity through solar panel, which generates a DC current. This electricity is then converted into alternative current using an inverter over here. Simultaneously, surplus electricity can be used to perform water electrolysis, producing hydrogen for later use. The generated hydrogen is stored and feed into fuel cell, where it reacts with oxygen and air to produce electricity through electrochemical process. This electricity is then converted to AC if necessary. The system also includes the component of load distribution, battery storage, which is an optional one, and a control and monitoring system to manage the operation of all elements. So, here we have considered the different configuration of hybrid system. Here in figure 1, hybrid solar wind power setup has been shown. This is an lab prototype model which has been taken from some certain source which I have mentioned over here. So, generally it is in a research phase where the different hybrid system are combined together for the generation. Once it is going to be completely configured and go for the commercialization phase, this system can be used in a widespread for all the commodities to ensure the energy sustainability. Here figure 3 shows a hybrid configuration where the fuel cell has been integrated over here. In this cycle, the high temperature fuel cell has been integrated, where that is solid oxide fuel cell. This is a high temperature fuel cell which is having a operating range of 600 degree centigrade to 1000 degree centigrade. Here a 2 compressor and a 2 turbines we have used over here. This 2 compressor we are going to supply one with air and another with a pressurized fuel, which is been transferred to in a heat generation system, where the waste heat from the gas turbine is further been utilized as a waste heat recovery system, and which helps in the charging the 2 streams which is been passing through it, that is the pressurized air and pressurized fuel, which is further heated, which helps in better reaction over here in the fuel cell. The unreacted fuel is been then allowed to pass through combustion chamber, where the its burning takes place and helps to reach the desired amount of turbine high temperature, where the exhaust gases are going to be expanded. This the product of unburned product of combustion or combusted gases are expanded in turbine, and the byproduct of this turbine are further been sent to a power turbine over here, which is not connected with the common shaft over here. This power turbine generate a excessive power, which is can be further been coupled with another gas turbine or any inverter, depending upon the requirement over here. So, this is a hybrid system which includes gas turbine and a fuel cell, where it is uses waste heat to recover from these streams over here. Here figure 4 shows the hybrid system where the PV panels are being used and to harness the rainwater as per the requirement. So, here the components we can see a house is been there with a battery and a generator and a control and monitoring system, where a turbine is there. Here the water is been stored at some elevated height, which is allowed to be passed through a turbine. Once the turbine is going to be comes in a action, it is been coupled with a generator through which a electricity can be produced. Similarly, in when the environment or climate is going to be open, when ample amount of sunlight is there, we are going to have an power from this PV panel, which is further been connected with a generator over here, and through which a control and monitoring can be done. So, here we can see the two systems over here, that is the rain water harvesting through hydro power generation and PV generation for solar power generation. So, here two different systems has been combined together. Thank you.